So integration of OpenFT systems into cloud, that is what we have worked, what we already have for classic KNopen in specification 301. The motivation looks similar because device description would be a part of services, gateway, network communication, and so on. If you want to transmit them is also standardized industrial automation based or TCP/IP and XML technology. Although TCP/IP and IP is only one of the network technologies, there could be others. So the specification 309 that we have for classic KNopen states for other networks, whatever they are. Anyways, the difference between the previous and this one, that is about network. What is that specific in there? So the first way, as Rainer mentioned in the very first presentation of today, logical network addressing by means of KNopenFT, long USTO. Then there is standardized reference designator for logical system-wide addressing. There's the points that have to be integrated from the start into this to allow standardized design of the hierarchically based networks, where KNopenFT could be one of them, or could be multiple KNopenFT networks or various different ones. Not to forget condition monitoring, which is a topic. It is, however, designed not KNopenFT or KNopen-wide for profiles, but currently for only one application profile of ours for Lift. If we have no request received by now for designing generic condition monitoring for everybody, for every device profile we have defined by CiA automation. If you see this one, you're welcome, of course, to provide such one. Also, cybersecurity considerations is reached to the next presentation of today. But here we had more of it for cloud inside, at least in a basic 309 specification for classic KNopen. We managed to introduce at least rudimentary authentication methods, at least REST for HTTP mapping requests in there, but we will come up with this later. So 2 slides coming up your way. Internet of KNopen Things. We thought in the times, it's already, I think, 7, 8 years maybe, when it is started. Internet of Things, we started with our KNopen Things, and now it will be KNopenFT Things. The basic scheme remains the same. We have KNopen network, maybe plenty of those, and we have somewhere maybe in the same production hall, production line, we have laptops or tablets or whatever, smartphones, which can be used to control, monitor, and diagnose, perform diagnostics on this production line or on a simple network. It is given in the same place with the network, but using the IoT, we could do this far remotely from a very distant location. So this black box IoT is quite interesting. What is behind this? And this is actually the infrastructure that should be providing all these services around the globe. So what we defined is a very low-level KNopenFT gateway. In the bottom of the picture, there is a small KNopenFT network, and there is a gateway we defined with possibility to have web servers inside, web clients inside, to offer the bi-directional access from web server even to web server, as some of our CiA automation members, for example, Lift Group, have already realized in their implementations. Although they have not took our specific CiA open-based TCP/IP gateway stuff, but still, this is the way how the things are going even right now. This is basically about this one. That now we go to what is exactly the requirements of the user, who would like, who would need, and what kind of access or what kind of capabilities for having access can open the FD devices or getting information from those devices. In the case, for example, of diagnostics, so conditional monitoring, or even just controlling remotely of this system. So first of all, that end user might have no knowledge of CAN, might not be capable to have, not capable, but is capable surely, but might not need to have CAN OpenFT knowledge. It should be actually restricted to very simple stuff like lamp 1 or lamp 2 on off, such things, and it should be remotely possible to operate such functionality. Behind this operation, as it states in the first one, as a logical addressing, there will be the real CiA OpenFT features down in a network, accessing certain device parameters, or settings activating this specific functionality. Another things, and end use, of course, use the internet, recent internet infrastructure, standardized protocols, RESTful, WebSocket, MQTT, SOAP, whatever it's now also available, and would like to access his functionalities from such networks. The data representation, as we said already, should be standardized. This XML is quite a good as markup language for not only data exchange, but representing of the data structures and protocol and service structures as well is quite suitable. However, JSON as a JavaScript is also possible, and wins on also gets more acknowledged from the user community. However, it still remains, XML still remains in large and will be probably for the next years. Another thing is, of course, to provide this interface in multiple languages. This is already covered, can be done using XML, certain website, certain internet technologies, certain HTTP designs, and so on. Then the end user would have also multi-level access, should authenticate or has to authenticate himself. Cybersecurity management should be in place, also defined from the beginning. So another point of view is, of course, the design of this network that the user uses. He has to know all this stuff which is below, namely the CiA OpenFT network, embedded network, what is gateway, how to configure it, where and whom to assign the user access, should be aware of also of cybersecurity measures he employs and activates for end user. Again, the same applies here. Data exchange technologies such as JSON, XML, then protocols and services, internet protocol services such as RESTful HTTP, web server, and so on. WebSocket for event-driven communication, MQTT, SOAP, other stuff, and also design of the can open devices on this low-level embedded network with even not only configuration description, but maybe also with such kind of nodeless CPJ as the topology design. So you know every time which device, where it is located, where it is exactly located in the network from the physical point of view. So we thought a concept from the low-level CAN-FT network, can OpenFT network, up to this gateway, from a single device up to this gateway, in this same can OpenFT network, which submits maybe even transparent information from the network in HTTP-based protocol, submits to further IoT infrastructure, such as would be next stage of gateways, possibly also this kind of edge gateway that has take information between the gateways of the network and push it into the IoT-based systems up until it goes into cloud services and returns back with its requests or responses in this way. I would just put a few words into this whole linking structure. We thought, of course, that on a very low level, the devices should provide certain attributes, such as kind of designators. We have already in Classic and Open a name denotation, which was suitable for every possible kind of labeling of this device, of this parameter. First place, this parameter denotation belongs to the parameter, which could be uniquely identify the parameter itself. There was nothing, however, for the whole network and a location of the device. This is where we come up with the next stage. How does it look like? And these all things with network designs will be put in a reference designator. There are actually 3 of them defined. First of all is a device, object, a parameter, device, and network. 3 identifiers, and they could be astoundingly located, but true, they are located in their device description in itself. So from the beginning, the information about device parameters, and a network, this device could be submitted with its description into the host controller, who then manages and submits this information even transparently into the host controller of the multiple hierarchical stages of controlling of this system. So this nice block diagram just illustrates what we had, and we can reuse and partially adopt for CAN OpenFT. This scheme exists already for Classic CAN Open. So what we change by replacing this with new specifications for CAN OpenFT, reusing the same kind of protocols, adding new ones. And what I've meant and written here as the arrows, this is what we have still to do: programmable devices, process imaging, converting or updating, can OpenFT access, can open access from other networks to map into CAN OpenFT protocols. This is still what we have to do. There is much done already. Basic and open specification 1301 now has some pretty amazing features, allowing to access networks, creating logical networks within one and the same physical network. allows using long-distance USTO to submit data across multiple transparent or even intransparent gateways across multiple networks, finally getting into a network which may submit its data into cloud services. But in this case, there are certain developments that don't need to be redone or updated or changed or modified. It is already here. So long distance USTO is a little bit more than what we had already, remote STO protocol, which required, of course, additional configuration, which is not necessary now with long distance USTO. And with long distance USTO, I can submit data across multiple gateways until I get to that one that needs the whole information without any additional configuration capabilities and necessity. Beyond this thing, so it was a little bit quicker than a part of this stuff. I would like to show you examples emerging also from the existing 309. This access can open access to multiple to other networks, where we defined already plenty of things helping us submitting data across networks with unique identification. Here is just an example of one single CanOpenFT parameter made already with new XML-based device description I've mentioned in my previous presentation. And here is the position. You can verify that object type and data type are correct in this case. And as you see, I've marked also with another color, if you can recognize it, with a green color, param reft, is this naming for parameter-related reference designators. Again, we have 3 of those in each device description. One, because device description goes not only for device, but may contain also additionally and may be generated a whole network profile of or even system of this. Then simple singular device description contains only parameter reference designator, and at most it can contain device parameter, device reference designator. Network profile would contain, of course, the reference to the whole network in this case. This is but just a simple example. Where do I find my parameter reference designator? And it does has here naming A02, Y01, and Z12. This means actually that recursively every reference designator may refer back to the other reference designator, uniquely defining with one designator the whole system where it is actually located, which network, which device, and the number of parameters, for example. Then how can this all be mapped into services which is getting into gateway from CanOpenFT network using USTO, maybe even long USTO, and how they will be converted into HTTP readable, possibly also, as in this case, this is example of RESTful HTTP read request. So we use, of course, this advanced BNF command syntax. This is special thing for internet-based protocols. There is another one we use for our ADS, but this is another stuff. And this command syntax is the very same or very similar to that we use already in our specification for RESTful HTTP mapping of CanOpen services. So this means adoption to the new services will be quite a quick one. What is still required? The whole stuff I've discussed actually reduces in most into the specification, which can be used to define all these nice features, including this reuse of nice CanOpenFT protocols, new protocols, adopting this, providing accessibility for the gateways, accessibility to higher hierarchical networks, allowing to generate RESTful HTTP request, WebSocket request, and map data from embedded CanOpenFT network into further cloud services. So briefly list what we had and have and what we need to get these things into CanOpenFT and what is still missing and what we may still be needing to do. User management. There are already several access levels, user, simple user, super user, and full access, for example, USTO, emergency message, and some other key protocols had to be updated in contrast to 309 because it is what CanOpenFT has. We had already authentication mechanism in the consideration of what we come up with cybersecurity. This mechanism may be extended further. System-wide reference designators, parameter reference designator, device reference designator, and network reference designator are already there. So we just have to keep them and represent them also in CanOpenFT version of 309 specification. RESTful HTTP mapping from CanOpen into that is also done. Is slightly simpler because we had just to add USTO, new emergency, and some other protocol changes, and that's it. Surely we need to introduce MQTT and SORP, but it is on request. We have not had this also in classical CanOpen, but we have to manage this as well. Also here, I would point out to the related standard specification, which you have seen already in previous figures and block diagrams, which functionality we need to have. And we decide if we have to adopt and how we adopt them for CanOpenFT. And those can be used in some kind of designs of your new network. So, repetition of what we have already. So that will be brief summarization of what is ready for you to use. Specifications, device description, MQTT and SOAP for CanOpenFT is still work in progress. Other stuff like cybersecurity would be very nice we hear in the next presentation. Thank you very much.